See the given problem. For a vector a bar, a cos theta I cap plus a sin theta j cap, find a vector b bar such that its magnitude is b and it must be perpendicular to a bar. There are four options given for this question, but the condition here is in order to answer this question, we should not use dot product. So that is the twist here. So if you want to try this question, just pause this video and try it. Now see, without using dot product, we want to find the perpendicular vector for a given vector, and its magnitude is given already in the question. So my way of understanding this problem is, let me first draw how a bar is in a two-dimensional plane. So I am drawing a two-dimensional plane. So this is x-axis and this is y-axis, positive x, positive y, and this is negative x and this is negative y. So my way of understanding this problem is, first I assume this as a bar, okay, and let me consider the angle made by this a bar with x-axis is theta. Therefore its x component will be a cos theta. Similarly, its y component will be a sin theta. So this is the location of the given vector a bar. Now we want to find a vector whose magnitude is b and it must be perpendicular to a. So that what I am trying to do here is, I am just considering, let me take a separate color. I am just considering a new vector. That vector must be perpendicular to vector a bar. So that's why I am drawing one more vector here. Let me consider this vector whose magnitude is b, and the angle between a bar and b bar must be 90 degrees. So this is 90 degrees. Now if you observe the angle between b and negative x, we want to know now. Total is a straight angle, so when you subtract 180, means when you subtract 90 plus theta from 180, you will get 90 minus theta. Therefore here you will get 90 minus theta. In order to find its x component, we need to drop a perpendicular to x-axis, and in order to find the y component, we need to drop a perpendicular to y-axis. Now what is this vector? Magnitude is b and its horizontal component we are finding, and it is along negative x-axis. Therefore I am keeping minus for this. So b cos 90 minus theta into I cap, and vertical component is positive, that's why I am considering positive. So b sin 90 minus theta into j cap. Okay, now cos 90 minus theta is sin theta, therefore it is minus b sin theta. Let me consider this as b sin theta I cap plus b cos theta j cap. Okay, now see, if you see the options, you have not observed this option, is it right or not? It does not mean that we did wrong. We did nothing wrong. We found one of the vector which is having the magnitude of p and perpendicular to a bar. We need to find one more vector. Okay, so in order to find one more vector, instead of moving here in the first situation, I moved in anti-clockwise direction. Now I am moving in clockwise direction, so that you can have this vector whose magnitude is b. Now we want to know this angle between the x-axis and this b. So what is this total angle? Total angle is 90 degrees. Now this angle will be 90 minus theta. In order to find the horizontal component of b, we need to drop a perpendicular to x-axis, and in order to find the vertical component, we need to drop a perpendicular to y-axis. Now 90 minus theta, in this case x component is positive, so b into cos of 90 minus theta into I cap, and if you want to y component, it will be negative, so b into sine 90 minus theta j cap. Okay, now b cos 90 minus theta is b sine theta I cap. Next, b sine 90 minus theta is b cos theta j cap. So we got one more vector. So these are the two vectors. So this is the first vector. Okay, let me give me a box for this. So this is one vector which is perpendicular to the given vector and having a magnitude of b, and this is one more vector which is having the same magnitude but making an angle of 90 degrees with the a bar. Okay, so this is first one and this is second one, but out of the given options we can have this in option B, so we can consider this as a correct option. This will be also correct option if it is there out of the four given options. So the thing that means here I did not use dot product to solve this question. If you use the dot product, you can find easily. If you find the dot product between a bar and all the four vectors, and if the dot product is 0, you can consider it as a perpendicular vector. Okay, in this way, by using our logic, we can find the unit vector which is perpendicular to another vector. I hope you understood this concept. So thank you very much.